Hello everyone. Today we are going to derive the stiffness matrix for a bar element. Here we are given a bar element having the sides AA and BB. The length of the bar element is L. In this element we have two coordinates. The first coordinate in the side AA, it is acting towards the right side. The second coordinate is in the side BB. It is also acting towards the right side. Since there are two coordinates, the size of the matrix will be 2 cross 2. That means we will have two rows and two columns. Now we are going to make the restraint structure. We know that on both of the sides the bar is free to move because there is no restraints. Now we are going to change the ends as fixed, so there will be no moving. You can see that now both of the ends of the bar are fixed. This structure is called the fully restrained structure. Since both of the ends becomes fixed, there will be no change in length. In the stiffness matrix, now let us find the first row. For that, in the first coordinate, we have to apply unit change in length. Our first coordinate is in the end AA. So in the coordinate direction, we have to apply unit displacement in AA. You can see that in the first coordinate, I have applied the unit change in length. In the matrix, to find K11, we have to find the load which causes this unit change in length. We know the formula for the change in length, PL upon AE. We know that here we applied unit change in length, so delta L is 1 and the load is PA. Let us take L upon AE on the other side, so it will come inversely. So for the load PA, we are getting AE upon L. For this unit change in length, this load should be acting towards the right side. We have kept our coordinate towards the right side. So the load PA will be positive. To find K12, we have to find the load PB. We know that the end B is restrained, so there will be no change in length. To avoid the change in length, a load should be formed in the opposite direction of PA. It will be equal to PA. So PA and PB will be same. Only the difference is that PB is acting towards the left side. So it will be negative. For K11, let us apply PA, and for K12, let us apply PB. Now in the stiffness matrix, let us find the second row. For that, we have to apply unit change in length in the second coordinate. Our second coordinate is in the end BB. It is acting towards the right side. So we have to apply the unit change in length towards the right side. You can see that in the end BB, I have applied unit change in length towards the right side. Now let us find K22. For that, we have to find the load PB. We know the formula to find the change in length, which is PL upon AE. Here, change in length is 1, P is PB. We can take L upon AE on the other side. It will come inversely. So PB is AE upon L. We know that we have kept our second coordinate towards the right side. To make this change in length, the load PB also should be acting towards the right side. Since it is acting in the coordinate direction, it will be positive. Now let us find K21. For that, we have to find the load PA. We know that PA and PB will be same, but PA will be acting in the opposite direction. So for PA, we have to just apply a negative sign with this. So K21 is minus AE upon L and K22 is AE upon L. In this matrix, we have found all of the elements K11, K12, K21 and K22. Let us apply all of them. A upon L is common in all of the members, so let us keep it outside. Finally, we have made the stiffness matrix in a bar. Now we are going to end this session. Thank you for watching this video.